The distribution of y given x is uniform on the interval 0x. The marginal density of x is 2x. Determine the conditional density of x given y. Okay. So the first thing that they gave is the distribution of y given x. So that's f subscript big Y, y given x. So they give us to be uniform on 0x, which means it's 1 over x minus 0. So 1 over x, y between 0 and x. Because remember, uh, this variable or this variable is the one on which you are putting the bounds. This. Okay. So next thing they gave is that the conditional density of x, the marginal density of x is fx equals 2x. And remember that we can write a subscript x here, or if we omit, then it means it's understood. So I've just written the subscript x so as to keep all notation consistent. So that's equal to 2x when x between 0 and 1. So these two will help us getting the joint PDF, because remember we've used this a few times. Joint PDF is equal to f of x times f of y given x. So fxx is 2x, f of y given x is 1 over x. So these two multiply to give us a 2. And that's for this region, x between 0 and 1, y between 0 and x. Now we are asked the conditional density of x given y. So this is what we are asked, conditional density of x given y. And for this, we will first need to find the marginal density of y, fyy, and you will see in a moment why we need this in order to find the required conditional density. So now recall the marginal density of y is found by integrating with respect to x, integrating the joint PDF with respect to x. Similarly, remember that we did it in an earlier problem where we had to find the marginal density of x, so fxx. So that's found by integrating the joint PDF with respect to y. So whichever marginal density you need, you integrate the joint PDF with respect to the other variable. So now when we are integrating this with respect to x, we need to know the x bound. So we can't right away use the x between 0 and 1 in general, because remember, this is the kind of region where the bounds, one of the variables will pick up the variable bounds and the other picks up the constant bounds. And you always go for putting variable bounds if possible. So we draw the region. Y is equal to x line, we know is this one. And then we have y is less than x. So that's this portion, y below x. And and the x is from 0 to 1, so x goes from 0 to 1. So it's this triangle. And now, since we are searching for the x bounds, so the way you do it is, if you're searching for the x bounds, you draw a horizontal, a typical horizontal strip through the region. And similarly, if you're looking for the y bounds, if you have to find the joint density, the marginal density of x, then you will be looking for the y bounds. Then you will be drawing a vertical strip. So here we're looking for the x bounds. So we draw a horizontal strip through the region. And now we see that this is a typical horizontal strip. The left end of the strip will always be at x equals y. And the right end will always be at x equals 1. So that's why x goes from y to 1. See, y to 1. And the joint density function was 2. Yeah, we found above the joint density is 2. So you integrate 2 from y to 1 with respect to x, and Integral is 2x. This goes from y to 1. And you substitute, you get 2 minus 2y. And so now remember that fx, the joint density, can also be written like this: fyy, f of x given y. And this is what we had to find, f of x given y. See, this is what we had to find. And that's why, since if you want this in the equation, then the other term over here has to be fy. And that is the reason why we found this fy. So the joint density we know is 2. Fy, y we just found to be 2 minus 2y. And this one has to be found out. So you take the 2 minus 2y down. So after simplification, you get 1 over 1 minus y. And that is choice E.